Oh my goodness. Okay. I'm kind of wobbly. That made me cry. All right, so we're going to get to our plenary round of talks this afternoon or this morning, and so for our first educational talk, we do have an original gangster in the room. His name is Dr. Nick Johnson. He's from the Virginia Commonwealth University, and he's going to give us a historical review of FSHD. So if I could, oh, there you are! Yay, Dr. Johnson. Thank you. Will you be on my rope team?
Great. Thank you. And good morning. I agree with Beth. I don't know how you follow that talk. So I'm going to have to talk to the organizers next time we do this. But it is my pleasure to be here and excited to see so many of you in the room and reconnecting with each other and with us. And so I was tasked with the duty of kind of trying to bring us up to where we sit today in 2024. And I think I have to say, if you reflect on what you're going to hear throughout the conference today and tomorrow, and what you've heard this week from researchers, I really do think that we are at a point in FSHD research where everybody's going to kind of remember 2024. This was a big deal year. A lot of stuff happened. And we can really see that we're kind of moving forward in terms of treatment. But before we kind of move forward and think about what a future holds, how did we get here? These are my disclosures. So really amazing progress. If you really think about it, FSHD was originally described in the 1880s, and when the family inheritance was really described starting in the 1950s. It took, as you can see there, from 1982 to 2010, really to describe the genetic cause of the disease, which is actually pretty impressive. But here we sit now in 2024 with 3 active clinical trials, multiple more in the pipeline, as you'll hear tomorrow and later on today. And so really, I think we're kind of at that point where we've had a slow roll to kind of get to this place, but just incredible progress in terms of thinking about it. So everybody in the room knows this, but FSHD, asymmetric, regional, and highly variable, some of the challenges we think about in terms of clinical trial design affecting the face, scapular muscles, humeral muscles, perineal quadriceps, and the abdominal and core muscles. In the original description, as I found this picture from Wikipedia, was originally described by Landuzzi and Desjardins in 1884. So they described 2 brothers actually with a childhood progressive muscle atrophy affecting the facial muscles, which they described as distinct and different than Duchenne. That's really the first recorded description of FSHD was way back in 1884. But we started to pick up steam in the 1950s when Tyler and Stevens, who were researchers actually at the University of Utah, described a kindred of 1,249 individuals that arose from a single ancestor. And so you can see this is one of the pedigrees here, and the original affected individual emigrating from England to Utah, and then having a number of offspring, which you can see there. And this kindred is actually really important in the history of FSHD and how we think about the disease. So it really was the first to establish the autosomal dominant inheritance, which means we know that the disease passes each generation. And then later on, researchers again at the University of Utah, led by Kevin Flanagan at the time, were able to describe actually that the mutation is stable between generations. So as opposed to other things like myotonic dystrophy, where you can see the mutation change, in FSHD, we know that mutation is stable between generations. And so I think that concept and idea opens up a number of ideas or research avenues in terms of thinking about how the disease is in fact so variable. And then, in a little bit later on, and now not in Utah, but across the ocean, George Padberg performed really seminal linkage studies in 1982s. And so at the beginning of most research articles about FSHD, that seminal thesis is referenced as really kind of the key moment when we started to hone down and lock in on the genetic cause. But then multiple groups really had to narrow the location in the 1990s. And that really culminated over multiple decades of work. I think FSHD has one of the most complicated genetic mechanisms of action out of any disease anywhere in medicine. This was really brought forth by this article in Science in 2010, which very simply says that in order to get FSHD, you have to have two things. You have to have a shortened D4Z4 repetitive element plus a permissive haplotype called 4QA and hypomethylation of that D4Z4, and that leads to FSHD type 1. And FSHD type 2, you have to have this SMCHD1 mutation, this permissive haplotype, and then hypomethylation of the D4Z4 repetitive element. Even if you think about this, I have to say a lot of times I have medical students and residents that don't understand. I mean, this is very complicated genetics. And so I appreciate all of you in the room who are able to think and understand that. I think one of the key pieces in terms of thinking about the treatments, though, of FSHD is actually because it's so complicated. It's like a Jenga puzzle, and so all you have to do is maybe pull one of these three elements, and you're able to kind of see treatments emerge. So hopefully that genetic complexity makes the treatments more possible. But really, this is probably one of the most important pieces of research in the history of FSHD, and actually one of the contributing authors to that, Rabita Will, is having his retirement party today in Rochester, New York. So, really a shout out to that group. Again, moving through some other kind of key important pieces. So how important is the repeat length in FSHD type 1? This is a key natural history finding. It's, you are likely predictive of a more severe phenotype if you have 1 to 3 repeats. In other words, a really short mutation or more severe, and over 4 is less predictive, and this may be affected by modifiers in methylation genes. Some of this work actually comes out of the registries that hopefully all of you are contributing to or signed up for, and so just another kind of important point to say that these data were contributed by you over many years in terms of thinking about how the disease is progressive. And then actually probably most important, again, thinking about clinical trials, and this is work done by Sabrina Ciccone, and you're not supposed to pay attention to that graph, but actually it was really an important finding to say, what's the difference between FSHD type 1 and type 2? They are genetically distinct, but clinically no identified difference. And so that really was an important piece and allows the entire community to be included in many of these therapeutic trials. I will say, as a corollary to that, or a potential issue, is that this does increase the diagnostic complexity. And so I think one of the things we need to think about as a community is how to educate our general practitioners, general neurologists, because, as I showed 2 slides ago, it's kind of a complicated diagnosis. We need to provide those resources as a community to allow people to receive an appropriate diagnosis. Okay, so that really kind of brings us to a point where now people are starting to think about, well, how do we treat FSHD? And so looking back, some of the earliest trials, and for the other researchers in the room, I should say this is not an exhaustive list. I tried to kind of pick through things that I thought were important to show. So early on, there's a trial of albuterol actually by Rochester and Ohio State University, but that was ultimately negative in the early 2000s, but it did establish this early focus on muscle strength and showed that muscle mass could increase. So this is a picture from a measurement of lean muscle mass. And so even though people didn't gain more function, they were able to show that using albuterol, you could actually increase muscle mass. And so that whole idea then led to 2 different myostatin inhibitors. So these are drugs that actually increase muscle mass that were tried in 2007 and 2016. And important to note that the FSHD Society recruited patients, but this idea of trying to increase muscle mass to compensate for the weakness that develops in FSHD is still actually in clinical trials now. So this is an idea that's really carried forward over the next 2 decades. Fast forwarding to the last 5 to 10 years, you started to see that the researchers have organized ourselves, and we formed the FSHD Clinical Trial Research Network, which has been led by Rabita Will and Jeff Statland. And the goal is to really hasten therapeutic development for FSHD by training sites and increasing patient engagement, refining trial strategies and developing outcome measures in clinical trials, to understand the patient impact, and to train the next generation of researchers and provide resources for industry. And I think as you hear the members of the industry roundtable tomorrow, you'll start to see that the ability for us to provide the foundation for new treatments to come into this space is in large part related to the work that's been done through this clinical trial research network. And you can see that it's been funded by a whole host of places, including the FSHD Society. And this is a map of the current FSHD CTRN members. So you can see it is actually really a worldwide effort to increase your access to clinical trials, as well as provide the data back required to, to do a better job to really show that we can recruit individuals into clinical trials. And these are the FSHD active studies. So the Resolve FSHD study, many of you have heard about this or participated in this, so thank you for that. So that was actually fully enrolled. There is a MOVE study that's actually continues to be open for enrollment, available at many of those different sites. And then there's, in addition to that, where you could have a muscle biopsy and MRI as well. And so if you kind of take this summary, so if you really think back from George Padberg's thesis in 1982 to all of the effort that was done to kind of find the gene and the genetic mechanism up through 2010, that really represents many, many decades of work and lots of research work, and has brought us to this point in 2024, where how can you treat FSHD? So this is, these are 5 ideas here. So you can use gene editing to restore that repeat. You can silence that locus, either through epigenetics or through modulation of the methylation. You could knock down or silence the DUX4 expression. And again, going back to that idea with the myostatin inhibitors, you could modulate muscle atrophy. And it's super exciting to see that out of all those different ideas, 3 of them have active clinical trials, which is actually pretty amazing. And so, I think this really is the turning point, like I said, where we start to think about the future of FSHD and how we might begin to move into the next 2 or 3 decades. Hopefully, we're not talking about 30 years of clinical trials to get to effective treatments. I don't think that that's going to be true. I think that we're seeing real progress this year. And so, up until now, this has really been focused on, what have the researchers done, what have the clinicians done, but this is a partnership. This is an engagement between individuals living with FSHD and people seeking to make those lives better. And we couldn't have done this without the FSHD Society. All through the world. And this is a picture actually of Dan Prez, who's one of the original co-founders of the society, testifying before Congress on your behalf to raise awareness and funding for FSHD. So you can see it was actually founded in 1991. I tried to list a few of kind of the key pieces here. So it actually advocated for including muscular dystrophies beyond Duchenne muscular dystrophy in federal programs, and most specifically in the MD CARE Act. And to really kind of expand on that particular point, the first versions of NIH-directed funding for the muscular dystrophies solely worked for Duchenne muscular dystrophy, which is an important target. But as all of you know, there are other forms of muscular dystrophy beyond Duchenne muscular dystrophy that have equal merit in terms of thinking about developing treatments. And so he really led the effort to expand it to all muscular dystrophies. And as a result of that, the Rochester Registry for FSHD patients and family members comes from that funding. The CDC efforts to define the prevalence of FSHD in the United States comes from that effort. The work in terms of understanding and establishing, MRIs as an important biomarker for clinical trials comes from that effort. Many of the early treatment ideas, including, the DUX4 knockdown, come from that effort. So you really, that ability for your foundation to advocate for successful funding, opens up this entire line of research, and it couldn't have been done without, like I said, the efforts of the FSHD Society. Beyond that, the World FSHD Day was established. There are many FSHD local chapters. I keep seeing the badges around here. I think that's an incredible resource that the foundation or society has provided to you all, and providing that local resource and support. There's an ICD-10 code for FSHD specifically that was advocated on behalf of the society, and that's a way for clinicians to code specifically for FSHD instead of just saying muscular dystrophy generically. The World FSHD Alliance was founded. There's an international care guideline, and it really, across the board has brought FSHD awareness and supported drug development. You heard Mark Stone talk about his visit to a biotech company, I think last month or within this month, and that's really, your society's working on your behalf to bring awareness and bring therapies to you. And more specifically, I think you'll hear more about this tomorrow more than any other time. Project Mercury is really this global initiative to speed the delivery of therapies for FSHD. So again, financially supporting research to find the cause and support clinical trial projects. Much of the research that I talked about on preceding slides was funded in part by FSHD Society, if not entirely. The society has supported recruitment. These trials and these studies don't work without your participation and engagement. And then spoken to the FDA in terms of the voice of the patient, thinking about FDA interactions. I think it's important to remember with FSHD, a lot of the challenges in terms of upper extremity mobility are significant and definitely affect people's quality of life. I hear it every day. And I think that that's an important thing. And I think if we were able to meaningfully improve, mobility through these treatment trials, that's a real opportunity for individuals to live better lives. The problem is that we have to prove that. We have to prove that to the FDA. We have to prove that to your insurers, to the public at large. And so that's really one of the efforts that will continue to work through Project Mercury. And, like I said, I started the talk that we could see the light at the end of the tunnel, because I really do think, I can remember early on in my career where it felt like this was today was very far away, but it's not actually, because we're here. And like I said, you're going to hear about some really exciting treatment trials that have had very promising results, not just today, but also tomorrow. And so once we get past that, it's really the beginning. So we have to, many of you here are the ambassadors. You're the ambassadors for FSHD, for your larger community. And so, once you leave today, please do that. Please be the ambassador. Take this back to your local community, to other patients, family members living with FSHD. Help engage them in the process once we get past approved therapies, because we need to, get people to access those therapies. We need to have better diagnostics, and then we need to make a point to say that these therapies are accessible to all individuals living with FSHD. I think on behalf of our center, thank you for your time today and all your efforts. I don't know if there's time for questions or not. Yeah, I can.
So any questions for Dr. Johnson? We have 5 minutes. We can take some questions.
One behind you.
Okay.
When you were on the slide about the Utah cohort, You mentioned that the mutation is stable between generations. Can you explain that a little more simple?
Yeah, it's always it's dense and meaty material. I appreciate that. So I think, the FSHD type 1 is caused by that cut in the D4Z4 element, and so that it gets short. And sometimes in other diseases, what happens is that that's unstable. So different generations would have different lengths of cuts, but in FSHD, each generation has the same exact mutation. So, if your grandfather had it, for example, you would have the exact same mutation that was present. And so that's an important piece that opens new questions, actually, because, the disease is so diverse. It's so different between different individuals. And so there are certainly groups trying to understand, are there other parts of your genetic material that make it more or less severe for you? Are those opportunities to develop new treatments? Are there other things people do, within a family in terms of exercise or diet or activity that say, well, this makes it more severe or less? And we know for a fact that women with FSHD tend to have a slightly later age of onset. So that suggests there's other parts of your genetic makeup that influence that. And so anytime that happens, that's an opportunity or opening to develop new treatments. It looks like there's one in the very back.
Hi, you mentioned that there are different pathways for treatments. Are there certain ones that are more promising than others, or that you think might come faster?
Yeah, so I'm kind of a spaghetti on the wall kind of guy. So I think right now we stand without an FDA approved or EMA approved therapy for FSHD. So the ones, I'm excited to see as many as possible get to a place where we're able to say this is an approved therapy that changes the course of the disease. And I think, if you look at, there's at least 5 steps when you could target it. I think we're looking at a very real possibility where we could be using combinations where you could, target, steps 2 and 3 or 4 and 5. And so, as these clinical trials come out, we'll begin to understand which ones seem like they're the most promising, but that doesn't mean even if, it's a second line therapy, it's not going to continue to be helpful and maybe provide a little extra boost. All the above. Question.
Good morning, all. 2-part question. Part 1, you mentioned that it would be important for more people to be diagnosed. I think I know why, but you didn't really tell us why. And the second part of the question is there more types of diagnostic testing available from general availability, ease of entry, cost reduction, et cetera, that you're?
Yeah, so the second part I'll answer first because it's a little bit easier. But, as opposed to some other disorders, it's actually somewhat difficult to genetically diagnose FSHD because you've got, type 1, type 2, maybe beyond that. And so I think there are genetic tests that will comprehensively capture any type of FSHD. If you live in the United States, like the University of Iowa Diagnostic Laboratory, that's very comprehensive and would capture any form of FSHD. But it's expensive. And sometimes insurance doesn't reimburse it. And that's a major challenge that we have, which brings me back to your first part of the question is why is it important to have more individuals diagnosed with FSHD? First, like I said, as you'll hear today and tomorrow, there's actually really exciting treatment trials that are coming to fruition. And so we want as many people to be able to access those as possible. And then the second part is that, as we make the case to say that these are important treatments and you should reimburse them for any patient living with FSHD, there's power in numbers. There's power in the number of individuals that we can say, have this condition.
Hi, speaking to the power and numbers of, people affected or involved, can you kind of speak to the latest thinking of how common is FSHD, like of people affected? Is it 1 in 100,000, 1 in 10,000? Just to get an understanding. And I know it's the most common form of muscular dystrophy, but in comparison to others, how common is it?
Yeah, so I think typically people say it's between 1 in 15,000, 1 in 20,000. I heard Mark Stone say earlier today there's probably about 1 million people living with FSHD worldwide. In terms of muscular dystrophy, it's probably the 3rd most common form of muscular dystrophy. Yeah.
What efforts are being made to get more physicians like yourself to become specialists where we can actually have access without going great distances and waiting in long lines to wait our turn?
Yeah, not enough. No, I think it is a major challenge. And I can tell you that our clinic wait list and many others are longer than I would like. And so I think, efforts within the FSHD CTRN to add sites to bring awareness in terms of the disorder. But having seen this happen in several other fields, the most successful thing that's going to happen is a treatment that's approved for the condition, because that really gets gets physicians engaged and aware that they need to do something about that. So if you look at disorders like SMA, where they've now got effective disease-modifying therapies, I routinely hear pediatric neurologists saying, "Oh, I want to do pediatric neuromuscular." So we benefit from some of that by itself, but we need to continue to provide those resources as closely as possible. And I know the FSHD Society has plans and ideas to widen the circle of physicians because it's not really fair to ask people to travel long distances for specialty care. Thank you.